This is Math 6, Lesson 6-3, Dividing Fractions. A reciprocal is any two numbers whose product is 1. So if I said 3/5, the reciprocal to 3/5 would be 5/3. If I said 2 1/8, the reciprocal to that would be 8/17. Because you have to change 2 1/8 into an improper fraction first, which would be 17/8, and then take the reciprocal of that, which is 8/17. Let's take a look at for a minute and talk about division for a second. If I took 6 and asked you to divide 6 by 2, you hopefully would get 3. 6 divided by 2 is 3. If I said, what is 1/2 of 6, which really means 6 times 1/2, you also get 3. If I said, what is 12 divided by 4, the answer is 3. Not that I'm trying to get all my answers to be 3 here. If I said, what is 1/4 of 4, 1/4 of 4 is the same thing as saying 12 times 1/4, we also would get 3. If you look at this, if I look at this, I divided by 2, or I multiplied by 1/2. I divided by 4, or I multiplied by 1/4. What's the reciprocal of 2? 1/2. What is the reciprocal of 4? 1/4, because this would be like that. Therefore, if you look at it, dividing simply is multiplying by a reciprocal. Let's take a look at something visually for a moment. If I said, let's take 4 and divide it by 1/2, that means we want to know how many 1/2s there are in 4. We want to know how many halves are in 4. So let's take 4 long rectangles here. If I said how many 1/2s are in 4, I can divide each one of these in half, can't I? I'm going to take and divide all my rectangles in half, and then I can count my halves. That's 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves. So truly, there are 8 1/2s in 4. That's what division is all about. When you think about division, you have to think about it by saying how many of this is there in something else. So if I said 4 divided by 1/2, if we go by what we learned earlier, what we talked about when we talked about what is 6 divided by 2, or 6 times 1/2, let's take that rule. 4 divided by 1/2, we already know the answer to that is 8. We just did it visually. So if I think about that, dividing by 1/2 is the same as multiplying by its reciprocal. The reciprocal of 1/2 is 2, and 4 times 2 is 8. That's how we get to the algorithm, or to the rule, that to divide a fraction, you multiply by its reciprocal. We didn't just make it up. Mathematicians just didn't wake up one morning and go, oh, let's just do this for fun. They actually had a reason behind it, because they understood what division means. They looked at pictures of it, and then they came up with, and they realized, oh, if I took something and I divided it by something, it was the same as multiplying by that one thing, my divisor's reciprocal. So, we have to know how to find a reciprocal. Okay, so we'll start with that first. Let's practice finding a reciprocal. The reciprocal of 3/5, you flip it upside down. That's what a reciprocal is. A reciprocal is two numbers whose product is 1. Well, the only way you can get 1 is, how do I get 3/5 to become 1? I multiply it by 5/3, because if I multiply it by 5/3, all these things cross cancel. So the reciprocal of 3/5 is 5/3. The reciprocal of 5/8, flip your fraction upside down, is 8/5. The reciprocal of 7, remember 7 is the same thing as 7/1, so the reciprocal of 7 is 1/7. And the reciprocal of 2 3/5 is not 2 5/3. Don't do that. Change 2 3/5 to an improper fraction first. 5 times 2 is 10, 10 plus 3 is 13, so that's 13/5. Its reciprocal would be 5/13. You have to be able to find the reciprocal, because that's how you learn to divide fractions. We already showed visually the picture that showed you what division was all about. So, to divide fractions, you multiply by the reciprocal. So if I took 1/2 and I wanted to divide that by 2/3, in other words, I want to know how many 2/3 there are in 1/2. Visually, that's kind of hard to do. But it means I'm going to take 1/2 and multiply it by its reciprocal of 3/2. And I would get 3/4. So there are 3/4 2/3 in 1/2. That's a lot of fractions to try to figure out. If I have it algebraically, a divided by b, a over b divided by c over d equals a over b times d over c, where b, c, and d cannot equal 0. Because b was on the bottom, c is on the bottom, and d is on the bottom, and you can't divide by 0. We've talked about division by 0. It's impossible. You cannot divide by 0. Remember my brownie example. All right, so let's take a look at dividing things. If I'm going to divide 1/4 divided by 3/8, I should do the rule which says, I need to know how many 3/8 there are in 1/4. Okay, that's what I'm asking. How many 3/8 are in 1/4? Okay, so I'm going to take 1/4 and I'm going to multiply it by its reciprocal of 8/3. And I will get 8 times 1 is 8, 4 times 3 is 12. I can reduce this because I could have cross-canceled. I missed it. That's a 1, that's a 2, so I should have gotten 2/3. Notice how much faster I would have gotten to my answer had I paid attention to cross-canceling. So there are 2/3 3/8 in 1/4. Okay, basically, I was telling you this. Here's a rectangle. We're going to divide it into 4 pieces. So this would be 1/4 right here. We want to know how many 3/8 are in 1/4. So you'd have to take this 1/4. So if all of these are equal, I need to take this 4th and divide it into 8 pieces. 1, 2, 3, 4, 5, 6, 7. So much for being equal. And then I need to say, okay, how many 3/8 are in there? So here's one set of 3/8. Okay. Here's another set of 2 3/8. Okay. So there's since this is a group of 3, right? And this is a group of 3. There are 2 groups of 3, 2/3 in 1/4. It's kind of weird, but that's the way it works. It's kind of bizarre to have to think about. Okay? And that's why it's so much easier to do by the algorithm than it is to try to do by the pictures. Let's take number 6, for example. 2/3 divided by 3/8. So 2/3 times 8 over 3. And here we can't cross-cancel anything. Too bad. 8 times 2 is 16. 3 times 3 is 9. 9 will go into 16 one time. Okay, 16 minus 9 is 7, so it's 1 7/9. Number 7 says 4 over 1 divided by 3/4, so multiply by my reciprocal, multiply by 4 over 3. I'm going to get 16/3. 3 goes into 16 5 times, because 3 times 5 is 15. 16 minus 15 is 1, so that's 5 1/3. Hopefully by this time in your math career, you're pretty good at changing improper fractions to mixed numbers and mixed numbers back to improper fractions. That's important. It's a skill we have to practice and we have to get really good at. Let's take a look at some more problems. Okay, some word problems. Here's where word problems get difficult because students don't know if they should start multiplying or dividing. Well, let's just think about it. It says a parking garage charges $1 for every 1/3 of an hour of parking. How much money will you need to park for 5 hours? So in other words, I need to know how many 1/3 are in 5. So that's division. I'm going to take 5 and I'm going to divide it by 1/3. I'm not taking 1/3 and dividing it by 5. Okay? I'm taking 5 and dividing it by 1/3. Oops, dividing it by 1/3. So that basically means I need to take 5 and multiply it by 3 over 1. So that becomes 15. Okay, so that will cost me, it will cost me $15. It will cost me $15 to park for 5 hours. Now, you could look at this logically, because think about this. It's $1 for every 1/3 of an hour. This is how we can check our problem. So 1/3 of an hour plus 1/3 of an hour plus 1/3 of an hour becomes 3/3 of an hour, which is 1 hour, right? If it's $1 each time, it's going to cost me $3 an hour. I had 5 hours. 3 times 5 is 15. That's a double way I can double check my own answer to make sure I did my problem correctly. Because 95% of the time, people divide the wrong numbers. They don't take 5 and divide it by 1/3. They take 1/3 and try to divide it by 5. But that's not what the question was asking. It was asking how many 1/3s were in 5. So this is a way you can double check it. If you think if you know, well, 1/3 of an hour is 20 minutes. There are 3/3 in 1 whole hour, or 60 minutes in 1 whole hour. If it charges me $1 for every 1/3 of an hour, it's charging me $3 an hour for parking, and I'm parking for 5 hours. 3 times 5 is 15. That's the great way of double checking to see if you are correct. Let's look at another problem. 6 people will equally share 3/4 of the cake. Who ate the other 1/4? We don't know. How much of the cake will each person get? So we need to know how many, we need to know how many 3/4 are in 6. We're like, oh, we have 3/4 of the cake. We need to divide it by 6 people, right? We need to take that 3/4 of the cake. We need to take the cake and divide it by the number of people, right? Because we need, if I told you you had 6 cakes and you had 6 people, you'd know that each person got a cake. If I had 12 cakes and 6 people, you'd go, oh, everybody gets 2 cakes. Because you go, oh, 12 cakes divided by 6 people. So we have 3/4 of the cake, and we need to divide it by the number of people. So it's the amount of cake divided by the number of people. Okay? So we have to do 3/4, remember this is over 1, times 1/6. 3 goes into itself once, it goes into 6 twice. So 1/8. Each person will get 1/8 of the cake. Which makes sense. Each person should get a small portion of the cake because there's only 3/4 of the cake left. Okay, so each person will get 1/8 of the cake. And this is how to divide fractions.